My name is Andrew Preston from Exchange Supplies, and in this screencast I'm going to show you how to set up this bloodborne virus computer simulation that was developed by Dr. Edmund Chatto-Brown from Leicester University and Neil Hunt, who's a freelance trainer and researcher, along with Exchange Supplies as part of the National Treatment Agency's Harm Reduction Works campaign. The first thing to say about the bloodborne virus sim is that it's not a predictor of the future. The real world is far more complicated than a simulation could ever be, but it's been designed to demonstrate and illustrate in a practical and visual way when different parameters change, the speed of transmission of bloodborne viruses between injecting drug users can alter rapidly. So when you launch the bloodborne virus simulation, BBV sim, this is the screen that you see, and around the edge are the various parameters that you are able to change. So the first thing you do is click the setup button here, and what that does is populate the virtual world in which the simulation takes place with a number of agents which has been determined on this slider here. So in this box now we have 300 injecting drug users, and their colours represent their bloodborne virus status. So green is healthy, red have HIV, the injectors who have hepatitis C are coloured yellow, and those that are black have both HIV and hepatitis C. So you can alter the number of injectors who have the different viruses by altering these parameters here. So we can increase our hepatitis C prevalence to say 60%, and we can reduce our HIV prevalence down to 1%. There. If you press setup again, the agents in the model are reassigned a bloodborne virus status, ready for the program to run. The other thing that you can see on the screen are these grey backgrounds, and those are sharing networks. It's representing injectors within these communities who are prepared to pass on or receive injecting equipment to or from each other in the event that they don't have clean equipment of their own. So just to show you the other parameters that you can change, the important one here is NSP reach. What we mean by NSP reach is the percentage of injectors who have all of the injecting equipment that they need for every injection. So you can vary that by moving this slider up or down. Yeah. Just clicking to the right or the left of the slider moves it up one notch at a time. So I'll leave the number of injectors at 300, but the important thing to know about that is that obviously if you populate the world with more people, they're more closely packed, there's more opportunities for people to be next to each other and able to form sharing networks. Conversely, if they're more sparsely populating the network, then the opportunities for sharing networks to develop are reduced. And that mirrors what happens in real life, that in rural areas you can have isolated groups of injectors who don't come into contact with people with bloodborne viruses, and so although they're sharing, they don't catch the virus. Although, of course, if the virus moves into one of those networks, it will spread very rapidly between them. There's a slider here for average injections per day, which we've set at 3, which is a sort of accepted average number of injections for illicit drug users in the UK. And then we've also enabled you to vary the mobility of injectors, so they're either able to move infrequently if injector mobility is low, or move around frequently if you set it too high. And again, with sharing group stability, allow you to model what happens in cities where often you find groups where the stability of the sharing group is very low and the people change and you have new people moving into networks on a more frequent basis, as opposed to groups where the stability is very high. So that's how you set up the bloodborne virus epidemic simulator, ready to press the run button, which will set off the simulation. I'll explain how that works in the next screencast.